Friends, today we are going to solve a beautiful question from JEST 2023, that section A, question number 17, and this is basically from oscillation. So it is mentioned in that question that you have a two mass m and 4m. They are subjected to a force F equals to minus kx, and they are restricted to move along x-axis. And also it is mentioned that mass m start from rest at x on t equals to 0 equals to a. I mean, this mass m start journey from right extreme position. On the other hand, that 4m mass starts from rest at x2 t equals to 0 equals to minus 6. Okay, and that force is given, that is F equals to, they are subjected to this force minus kx. So then the question is, at what point on the x-axis they will first collide? Okay, so there are four options given. You have a x is equal to a by 2, and then you have x is equal to minus a by 2, and then you have x equals to minus a by 4, and last x equals to 0. Okay, so first of all, they have different mass, but force constant is same. Now if I calculate that frequency of oscillation for, let us assume for this mass, for mass m, that frequency of oscillation omega will be how much? That will be simply root over k by m. Okay, but for this mass, for a mass, that frequency of oscillation, that will be root over k by 4m, and obviously that will be omega 1 by 2. The frequency of oscillation of for a mass is half of the frequency of oscillation of m mass. It means time period of oscillation, if the time period of oscillation of this mass is t1 for mass m, then the time period of oscillation of 4m mass, that will be t2, and that t2 will be equals to twice of t1, because there's an inverse relationship between time period and angular frequency. Since omega 2 is half of omega 1, so obviously time period of oscillation of 4m mass will be twice of time period of oscillation of m mass. Now see, it's interesting, these two options will automatically be cancelled here, because this mass started journey from positive extreme condition. It will take time to reach to the mean position. That time will be t1 by 4. How will do that? You'll have a t1 by 4, then t1 by 4, t1 by 2, then t1 by 4 again, 3 t1 by 4, then t1 by 4. That will be your complete t1. So the time required to reach that m mass from this extreme position to mean position, that will be t1 by 4. Okay, but time required to reach that 4m mass from here to here, that will be t2 by 4, and you know that t2 is nothing but twice t1. It means it will take much time to reach from this from negative extreme condition, extreme position to mean position. It will take t1 by t1 by 2 time. On the other hand, it will be only t1 by 4. It means this motion of m mass is, I mean, very fast as compared to 4m mass. So as a result, यहाँ से यहाँ तक जब आपका आएगा m mass, तो आपका 4m मास यहाँ पहुंच ही नहीं पाएगा, है ना। तो कोलिजन, तो ऑब्वियसली दैट कोलिजन कैन नॉट बी ऑकर एट दिस पोजीशन एज वेल एज एट दिस पोजीशन। यहाँ पे आपका हो ही नहीं सकता है कोलिजन, क्योंकि इनका जो मोशन है दैट इज faster as compared to 4m mass. So this option will not be correct. Only there are two options remaining. Now, if you learn that oscillation theory, if the particles start journey from right extreme, then x1 I can write that will be your a of cosine omega 1 t. Okay. On the other hand, if the particles start journey from negative extreme condition, then x2 that will be your minus a cosine of omega 2 t. So omega 2 is the frequency of this particle, that's why I am taking omega 2. Here omega 1 is the frequency of this particle, so I am taking here omega 1. Now I have to check whether this one will be correct or this one will be correct. So let me take this. Okay. So if both particles is having same position at same times, it means they will be collide. So I'll check that time required to reach this 4m particle at x equals to minus a by 2 this position, and time required to reach that m particle at x equals to minus a by 2, and I'll compare. If that time is correct, I mean if the time is matching, it means at this position there will be collision that will occur. So it means that both particles are at the same position at the same times. Of course there will be collision. So let me check, or let us check one by one. Now if I substitute that x2 equals to minus a by 2 for 4m mass, so on the right hand side you will have minus a cosine of omega 2 t. So this a will be cancelled, minus will be cancelled. As a result, you will get cosine of omega 2 t. That will be your 1 by 2. And 1 by 2 means what? You will have cosine of pi by 3. Right? It means omega 2 t equals to pi by 3. Or let me take different time. Let me take, this will be a t2. Let me take different notation. It means t2 will be pi by 3 omega 2. And we know that omega 2 is nothing but omega 1 by 2. If you substitute it, you will get t2, that will be 2 pi divided by 3 omega 1. So this is mass time is required to reach that 4m mass at x equals to minus a by 2. Again, if you check the time required to reach that x equals to minus a by 2 for m mass, if you check that, then you'll have x1 equals to minus a by 2, and that I can compare with a cosine of omega 1 t. And a will be cancelled, so it means that will be equals to minus 1 by 2. And let me take, this is t1. So it means minus 1 by 2 means what? Cosine of 2 pi by 3. So it means if you calculate t1 from here, you will get 2 pi by 3 omega 1. So I can see that both particles are observed to be at x equals to minus a by 2 at the same time. I can see t1 equals to 2 pi by 3 or 3 omega 1. T2 is also 2 pi by 3 omega 1. So it means that correct option, that first collision will occur at x equals to minus a by 2, because both particles are found are observed to be at this position at the same time. So this will be the correct option. And the question is very nice. Just you have to use that concept of oscillation. Thank you.